What if I told you that this billiard ball is actually mostly to blame for all of this? Our world depends on plastic more than ever before, and plastic just might be one of our greatest inventions ever. Microplastics have been found anywhere from Arctic ice to the placentas of unborn babies. That's pretty scary, right? But the thing is, they might have just lied to you when they said reducing, reusing, and recycling was the only option. Because what's really happening here is we're in an era of rediscovering and reinventing plastic. But in order to understand the future, you might just need to go back in time a little bit first. In the 1860s, this game, billiards, was all the rave. And the maker of the balls and equipment of billiards are making a lot of money. But there's one big problem. The balls that people are using to play billiards with are made out of ivory or elephant tusk. Needless to say, this is not a sustainable source of material. And new laws are starting to get enacted to prevent the hunting of elephants. Yay. So Phil and Colander, one of the biggest billiard ball manufacturing companies at the time, put up a competition. The price is $10,000. Which is the equivalent of $350,000 in today's money. The terms of the competition are quite simple. Who can come up with a better alternative to make billiard balls out of something that is not ivory? This guy, John Wesley Hyatt, is a printer working in New York and wants to rise to the challenge. Because through his work, he has seen the advances in printing material and photographic films and starts thinking maybe this is where the answer lies. He starts tinkering around, and with the help of his brother Isaiah, they invent nitrocellulose in 1869. The amazing thing is that for the most part, this is a completely natural material. It's a combination of camphor, which comes out of a tree and it's a sticky, gooey-like substance, with cellulose, which is a type of glue that comes out of all plant material, and they're mixing it with nitric acid and alcohol in order to create a substance that hardens and very closely resembles the physical properties of a billiard ball. They patent this invention under the name celluloid, and this becomes the world's first industrially made plastic. But there's one big problem that John has not realized yet. But in order to understand this, have you ever thought, what is actually plastic? Well, the word just means to be molded or make it be shaped into many different shapes. But if you zoom in, plastic is surprisingly simple. It's just a long chain polymer, which means that it's made out of monomers that link together, making long chains or a polymer. There's tons of different polymers in nature, like our hair is just a polymer of the protein keratin. But so are our nails or the hooves and horns of animals. They're the exact same substance. How can they feel so different and have such different properties? Well, this is where the magic of science happens, because depending on how you arrange all these little units, they can lead to drastically different physical properties. If you pack them closer together, like in our nails, you can get a keratin structure that's very hard and rigid. If you space them out a little bit longer, you can get something very soft and flexible, like our hair. And this is the magic of plastic. It's extremely strong, but at the same time lightweight, can be flexible or rigid, and all plastics are great isolators of heat and electricity. This is why most of your electronics and cords are covered in plastic. So what was the problem in celluloid? If it's made out of a natural material, why don't we use that instead of fossil fuel-based plastics today? Unfortunately for John and Isaiah, when celluloid was produced, if the temperature was not exactly right, it could become extremely volatile. And rumors started that if you struck those new types of balls really hard, they could even explode. John and Isaiah actually never got any of the prize money that Phil and Colander put up. But take a look at this. Plastic was just beginning. A German scientist accidentally discovers PVC, a very hard type of plastic. A few years later, Bakelite takes over the world, a new type of plastic that's based on formaldehyde and phenols. And everything comes to a head with World War II, where people need plastic more than ever. But believe it or not, with every iteration, it becomes clearer and clearer that the future of plastic lies in our ability to take fossil fuels and turn them into this polymeric structure. It's cheap, it's lightweight, and it's incredibly easy to produce. And that is actually because John and Isaiah had patented one more thing. And that would almost come to determine the entire history of plastics more than anything else that had discovered to date. I'll show you a little bit about that later. Which brings us to today. This is how much plastic we're currently producing in the world, and this is how much we will be producing by 2050, over 2 times more. But take a look at this chart. You might think that most of our plastic production is for heavy machinery or industrial purposes, but textiles, industrial machinery, and electronics all combined together account for less than 20% of our plastic production. The big chunk over here is actually packaging. You see, plastic was our greatest invention because it allowed us for the first time to store, ship, and transfer food and water in clean containers extremely cleanly and safely. The reason why packaging is super important, it's because it's also one of the largest polluters in terms of our plastic production. Over 95% of the plastic packaging we produce is single use, which translates to anywhere from $80 to $120 billion of economic loss each year. And you see, for the most part, we have been trying to iterate right here, which is how do we turn something that is trash into something that can be used again, like recycling? Or how do we make sure it doesn't end up in our oceans? But some very cool science is taking place in order to rethink this entire production line. Let me show you. You see, this is Julia Reiser. She's a scientist that is based out of Western Australia. She's the scientist that spent the majority of her career tracking microplastics and seeing the effect they have on the marine environment. And she had the same question: why do we only worry about plastic once it's already trash and don't try to fix the problem from its root? After all, there were lots of different types of polymers that had similar properties to plastic. Why don't we create a plastic that is not made out of fossil fuel? Well, because after years of research, she realized how to turn this into this. For decades, we have been conducting studies on seaweed. These incredible forests in the ocean can grow 10 to 12 inches every single day. And we have known that they can produce substance called polyhydroxyalkanoids, or PHA for short, that can replace plastic. But sadly, like a lot of plastic alternatives, it was very hard to scale. But what Ulu is doing is a little bit different. Let me show you. They are brewing a type of beer that starts with seaweed. They cook the seaweed in order to extract all the sugar. And you see this arrow over here? We'll come back to that. All the sugar is used as food for a type of microbe. These microbes have been carefully selected for two reasons. They grow in salt water. Not a lot of other things can grow in salt water, and seaweed is also salt water, so there's less risk of cross-contamination. But also it's very important for step 3, which is that when they get fat enough, you simply need to put them in fresh water in order to burst open and extract the BHA. With other types of natural plastic, you still need to use toxic solvents and very harsh materials in order to extract the final product. But step 4 is the most important part. Remember when I said that the Hyatt brothers had invented one more thing that actually outlived them? It was these machines. They're called injection molding machines, and their patent has survived many years. Because you see, all the plastic things that we make simply start with a little plastic pellet that gets warmed up and then injected into a mold that can become any shape we want it to. Sadly, a lot of the alternative plastic technology you see around is not scalable enough because it doesn't fit in these machines. What Ulu has created is a pellet that can fit into the existing machines that is 100% derived from natural materials. And remember when I said about the little arrow over here? Every living thing is practically a whole bunch of sugar, water, protein, and a very small sprinkle of metals, like calcium, potassium, or sodium. When you extract all the sugar and water, what you're left with is a very protein-rich substance. This protein, out of this plastic-making process, can go back into the ocean and feed aquaculture. The happy news is that Ulu is not the only one. There's other startups around the world that are tackling the same problem using different starting point. So if you want me to cover some of those, let me know in the comments below.